So welcome back to Computer Science 305. This is the last section of the talk on parameters, and so we're talking about specification issues, right? So this is so if we go back and think about when we talk about all these different parts of the language, like where does it come from? Is it a part of the language specification? Is it part of the actual language system? Where do these things occur, and where are they bound, essentially? So the question becomes: are these different techniques, are they part of the language specification or not? Well, that depends on the actual language itself, right? If we are not considering side effects, parameter passing technique may be undetectable by the programmer, right? If there are no side effects, then we actually may not actually be able to determine what's going on. But even then, if you do have side effects, identifying which specific parameter passing technique it's using you may only be able to determine it partially, right? For example, in Java, it appears that things are being passed by reference, but in reality, they're just being passed by value. The fact that object typed variables are references themselves does not mean it's not passing by value. It just means that that value happens to be the reference to an actual object, so it's still all by value. But the question becomes: so are the parameters always evaluated? So this is the other one, right? So we have eager evaluation, so it's always evaluated, or is it lazy evaluation only when needed? The difference here is obvious, that we don't necessarily always want our parameters to be evaluated, but knowing which one it is makes it so that you can utilize your language more effectively, and you can handle much larger data structures as needed rather than all at once. So these are things that we have to be worried about, and when we talk about cost models during the prologue section, we'll talk about why reevaluation can be expensive or not. Excuse me. And whether or not parameter passing will take time proportional to the size of the object, right? When you do have side effects, you can detect some parameter passing techniques used by the language system, but in some programming systems, the implementation detail that programs are supposed to depend on may not be part of the specification of the language, right? So, for example, oftentimes, these things can be overlooked. Like, we don't want, and may not even be something that is necessarily going to be there all the time, right? For example, if the language system currently implements maybe a more the capability to appear to be passing by a result, like gives you the capability to do by result, and then you start relying upon that capability, so you have an out parameter, but it's not something that was necessarily intended by the language itself, and you start depending on it, it can actually break the capabilities of your program later if they remove that, because it was not necessarily intended to be there in the first place. Case in point would be Ada, right? So Ada modes, right? In Ada, there are 3 parameter passing modes. So you have in, out, and in, out. In, out, and then in, out, right? So basically this is saying it's by value. These can be the in items are by value. You can read them in, right, but not assign them. They're similar. They act as constants, right? You can be out. They must be assigned to, but cannot be read. And then you have obviously in, out. They can be read and or assigned. Ada specification intentionally leaves some flexibility for implementations. So this is where it can become difficult, right? Even though the specification provides these, it does not necessarily guarantee the implementation. And so then you have copying is specified for scalar values, right? So in is value, out is for result, and then in, out is value result. Aggregates like arrays and records may be passed by reference instead. So you have, for scalar values, or what we'll call primitives in Java, we have this capability in Ada. It's saying that we can do, we know that in is by value, out is by result, and in out is by value result. But when we have aggregates such as arrays or records, or essentially objects, they may be passed by reference instead. So it's not that you have in out, it's just that you have in out. If you think of how the actual you have the capability to modify the reference, so it's by reference. Any program that can detect the difference, like some of our earlier examples, is not a legal Ada program, right? So that's a problem. But in reality, today we have we know for what we've done today, we've learned about how matching of formal and actual parameters actually occurs or can occur inside different languages. Being aware of that whenever you shift to a new language is always a key thing. We looked at 7 different types of parameter passing techniques. They're not the only possibilities, but they are the most common. And then we have to we came up with some ideas about how to draw the line between language definition and implementation detail. As I said before, these are not the only schemes that have been tried. They're just the most common. And then apparently there's a CS corollary to Murphy's Law. Inside every little problem, there's a big problem waiting to get out. Bear that in mind. Anyway, have a great day, and I look forward to seeing you all in class.